Welcome to EDU World Space.
Alright guys, we're doing problem number 78 of chapter 9 in Chemistry Essential Science. So this three-part question. First part is they want to know what paramagnetism means. So paramagnetism is a kind of magnetism whereby certain materials are actually weakly attracted to an externally applied magnetic field. So let's see. So if you have a paramagnetic material, you have a and you apply a magnetic field towards it, it will actually move towards a magnetic field. Excuse me. Diamagnetic is the opposite. If you apply a magnetic field towards a diamagnetic material, it will actually be repelled from the magnetic field. Yes. So that's why that's what paramagnetism means. Your magnetic field is parallel to the magnetic field you're creating is parallel to the applied magnetic field. So part B, how can one determine experimentally whether a substance is paramagnetic? Well, that's pretty simple. You would just apply a magnetic field and see which direction the material goes. If it's going to be attracted, then it's paramagnetic. So now they want to know which of the following ions would you expect to be paramagnetic? So we're going to do this step by step. We're starting with O2 plus. So you can actually determine whether something is paramagnetic or diamagnetic depending on the number of unpaired electrons in its molecular orbitals. So paramagnetic elements have unpaired electrons. Diamagnetic elements have no unpaired electrons. So let's look at O2 plus. We have our 2s electrons. Well, first of all, we have our electron configuration 2s2, 2p4. And then we have our 2s electrons. And now we're going to move where both the bonding and anti-bonding sigma bonds are filled. Now we're going to move to our 2p electrons. These are electrons that are actually involved in bonding. Because you can see with our 2s, you have actually both the bonding and anti-bonding orbitals. So you can't form any bond using your 2s electrons from here. So now here's S. Now here's our 2p orbital. We have our oxygen configuration here. This is a standard oxygen configuration. Now this is O2 plus, so that means one of our oxygens is going to be positively charged, it's going to lose one electron, so that's going to be on the right over here. So now we fill our molecular orbitals. We fill as so we have former sigma bonds. We're forming our pi bond orbitals, and then we're starting to put electrons in our anti-pi orbitals. So if you have an electron in your anti-pi bonding orbital, this electron is unpaired. So that means O2 plus, that will be paramagnetic. Now we're dealing with N2 minus. So here's the electron structure of our nitrogen. So we have our 2s orbital, now our 2p. So our nitrogen is going to be our N2 has a -2 charge. So we're going to add 2 electrons into our nitrogen orbitals. So now we're going to fill up our sigma and our pi bonds, and now we're going to fill up our anti-pi bond orbitals. So N2, it has 2 electrons. It has 2 electrons in our our antibonding orbital, antibonding pi orbital, and these are unpaired, so this will cause it to be paramagnetic. Now for lithium, we're focusing on our s orbitals as opposed to our p orbitals. So lithium's standard electron configurations is 2s1. So now lithium, one lithium will have one valence electron and the other lithium will have no valence electron. So that means that only one electron is forming your sigma bond. So that's one paired electron in your sigma bonding orbital. So lithium is also so L2 plus is also going to be paramagnetic because it has those electron. So it has that one electron. So it has that unpaired electron. Now for O2 minus, your peroxide ion, we have our 2s and 2p orbitals. So we're focusing on our p orbitals. We don't focus on our s because p orbitals was actually involved in bonding. So we have our electron configuration of oxygen, and since we have O2 2 minus, that means we have to add extra electron to each of our oxygens. So then after we do that, we fill our bonding orbitals. We fill our sigma, our pi bonding, our other pi bonding. And then we fill both of our anti-bonding orbitals. So since we have no unpaired electrons in either our bonding or anti-bonding orbitals, that means O2 minus is going to be diamagnetic. It will not be paramagnetic because we don't have any unpaired electrons. So when you look at these kind of diagrams, you have to understand the basic electron configuration of your atom. You have to be able to understand how these molecular orbital diagrams work. You have to understand how to set these up. You have to show the non-bonding, the bonding, and the anti-bonding orbitals, and that'll allow you to understand how to do this. And you also have to think about the definition of paramagnetism and diamagnetism.